we are going to learn about taking the square root of a complex number. So let's sort of, I don't know, I guess talk about what we're doing. This is a complex plane. Here we have our real numbers, and here we have our imaginary numbers. So both those axes together make the imaginary plane. Let's just work with the example that you were asking. 3 and then 1i. So this point right here. So we have 3 plus I. Okay, this is how we plot this point on the complex plane, and this is just, I guess, another way of looking at this number. I guess the same way that one would use a metaphor to describe, I don't know, this is kind of lame, but I'm so hungry I could eat a horse. And it's like, okay, you can't really eat a horse, but a horse is really, really big, and so to eat one you'd have to be really, really hungry. And it's a metaphor that helps you understand something that might otherwise be harder to just spell out. So this complex plane is, I just want you to think of it as a metaphor. It's like a horse. It's just an easier way to understand what's going on. And I know in school a lot of times it's not taught to be an easier way to do something, but it's supposed to be. So we're going to run on the assumption that this is helpful and easy and not just like an additional thing that one needs to learn. So this is the complex plane. We have our 3 plus I, and that can be, I'm going to use a different color there. Let's just make this, so here's our dot. Here's the line, which is R. And R also has a theta with it, okay? So we can close up this triangle here. Okay, so we're going to talk about de Moivre's theorem. De Moivre's theorem, you can make sense of it when you look at the complex plane. So our horse metaphor, our complex plane. If you just look at the numbers, I'll show you how it looks like with just the numbers, but then with this will sort of make sense, make the numbers make sense. Basically, first I'm going to write it out, and then I'm just going to erase this bit here just to make a little bit of room to write it out. I'll write it out, and then we'll sort of talk about what's going on. Okay, so good old de Moivre, in his brilliancy, came up with the following. I'm trying to choose a good color. What would be a good color? Okay, here we go. So if we have 3 plus I to any exponent, that will equal R to that same exponent times the cos multiple of that angle plus I sine, again, the multiple n of that angle. Okay, so what does that mean? What it means is if we take this exponent here and we put this to the n, okay, so if we're say we're squaring it, okay, so I won't put it to the n, I'll just say we square it, okay. It might be tempting to just say, okay, if we're squaring this, then we simply square this and we square this, and so that would give us 9 and then 1, so it'd be so let's say our 9 is here. You would think, okay, really simple, it would just be that, but it's not. Hopefully it knows. It's not. You don't simply square this guy and square this guy and then you're done with it. What you have to do if you're squaring this is you have to square this guy. Okay, so that's going to give us something that's going to be like a lot longer. Okay, but you don't just stop there. You don't just square this guy. You also have to multiply this angle by that as well. So this becomes 2. Okay, so not only is it that, but it's that with an angle that's twice as big. See that? So if this was, I don't know, not 2, let's say it was 3, what would we do? We would put this to the 3 and we'd multiply that angle by 3. So it'd be even big, like that way. What if this was to, I don't know, the 47th? This would then be to the 47th, and we'd multiply the angle by the 47th. What if this was to the 47,526? 7, 3, 2. Then you get the picture. Yeah, so whatever we do here to the n, we have to put the r to the n, and we have to multiply the theta to the n. Okay, so basically we square this and we multiply this, and that is this is a metaphor. See, when we use this way, hopefully I don't know, it's helpful in understanding what this means. So we square, if we were squaring, we would square the radius, and then we would multiply the angle by the n there. Okay, great. So in our case, what we're looking for is the square root of 3 plus I. So hopefully we remember that the square root of a number, so let's say we have, I'm just going to make up 9. The square root of 9 equals 9 to the 1/2. Those are two ways of saying the exact same thing. Okay, so if we have 3 plus, if we have the square root of 3 plus I, that equals 3 plus I to the 1/2. So what does that mean? That means this guy is a 1/2. Our n is a 1/2. So that means our r also has to be a 1/2. And instead of doubling this angle, making it bigger, we have to divide this. So it's 1/2 times our theta, which equals theta over 2. So what happens is this becomes the square root. I'm going to erase some of these. So if we were to take the square root of this, that will give us an r that's maybe, I don't know, that big, that multiplied by 2. I'm just sort of guessing. And then a theta, which would be half as thick as this one, which would be, I don't know, maybe something like this here. Okay, that would be our final answer. So we're trying to figure out what this coordinate point here is. Okay, it's going to be some number. Okay, so it's not simply the square root of 3 and the square root of 1. Okay, what we have to do is take the square root of r and then divide the angle by 2. Okay, square root of r, divide the angle by 2. So let's do that. Let's take the square root of r, okay, because n to the 1/2 is the same as square root, times all this. So now I bet you're wondering, how do I go about doing all this? Well, you know, it's getting a bit messy here. Nah, I'm not going to redraw that. It's okay, so cos of theta. So cos theta before we did, before we split it up like this, before we divided it by 2 was what? So when this was our theta, when we were just using the blue, when this was our theta, this had a height of 1, this had a an underneath like length of 3. So cos are SOHCAHTOA. Cos is adjacent over hypotenuse, so we had cos theta equals 3 over r. Okay, and then we had sine theta equals 1 over r. Okay, I'm assuming you've seen this before, so I'm not putting too much emphasis reviewing this. So you have some triangle. Basically, here, let's draw it really quickly here, just in case. This is our 3, this is our 1, this is our r, this is our theta. Okay, so cos theta is adjacent, which is 3 over r. Sine theta is opposite, 1 over r. So we just wrote that there and there. Okay. I forgot what we were talking about. What are we doing? Oh, yes. Okay. So we're dividing our theta by 2 and sort of seeing how that affects all this. There's a theorem that you use to figure that part of it out. So what we're trying to figure out then is cos of theta over 2 equals what? And sine of theta over 2 equals, if we divide this by 2, how does that affect this part here? Well, I'll show you that real quick. Basically, if we have the cos of theta over 2, that's going to end up equaling something that's going to look rather complex, but it's going to be the plus or minus. And the next like 2 minutes, you don't really need to learn, but if you're, I don't know, interested in knowing where it comes from, you can just keep watching one. Otherwise, you can skip the next 1 minute. And cos theta over 2, okay? Cos of theta over 2 equals plus or minus 1 plus cos theta over 2. And the sine of theta over 2 equals plus or minus square root. This is the interesting thing. We're going to do cos again, except it's going to be minus over 2. Okay? So this is the bit that it's beyond the scope of this video to go into why this is that. But just know that this is something that we implemented. Some other mathematician figured that out. Might have been DeMove as well. I think it was way before that though. And use that in this to figure out this part of it. Okay? So when you put in this here into this guy here, when n is a half, okay, so that's why it would be over 2. When you use this bit that we learned here and implement that in this bit here, you end up getting the following. And this is what you need to know. This is what you'll need to memorize. I'm just going to write out the final answer and then work backwards if it's helpful. What you need to know is a plus or minus b I, okay, square root equals the square root of r plus a over 2 plus or minus square root of r minus a over 2. Okay? If we have a minus sign here, that's when you'd have a minus sign here. You have a plus sign there, you're going to use the plus sign. So that's why it's plus or minus. Okay? So if we implement this into the question that we were talking about, 3 plus I square root equals, oh, but before we step forward that way, we need to know what r is. So for our case, so 3 plus I. So what is our r? Our r will equal 3 squared plus 1 squared. Right, r squared equals that. So r equals 3 squared is 9, 1 squared is 1, 9 plus 1 is 10, square root of 10, and the square root of 10, if you just plug into your calculator, equals 3.16. Okay, so our r is 3.16. So that's something you need to figure out. Whenever you're given one of these questions, you can just quickly figure out what r is. So back to this guy, 3 plus I square root. We figured out our r, 3.16. So then we just simply plug it into here. 3.1, so we have the square root of 3.16 plus our a. What is our a? Just that first number, 3 over 2 plus 3 minus 3. Oh, sorry, my bad. 3.16 minus 3 over 2 square root. So 3.16 plus 3 is 6.16. 6.16 divided by 2 square root plus 3.16 minus 3 is just 0.16 over 2. Hope you're following along. So then that equals, I get it mixed up. So then that equals 6.16 divided by 2 is the square root of 3.08. You can just use a calculator. I'm sure it's not a problem. And 0.16 divided by 2 is just 0.08. Okay. One thing I forgot to do. Very, very important. I apologize for not doing this before. There should be an I here. This is all I. Okay, so this one is without the I, this one is with the I. My fault. We gotta add that in here. So here we have I, here we have I, here we have I. Okay, it's outside the square root. Yeah, it's just this part of it is the real part, this part of it is the imaginary part. And then we go through, and then you can simply plug in 3.08 into your calculator and take the square root. It ends up being 1.77 plus, and then take square root of 0.08 is 0.28 I. Okay, and that's it. That's your final answer. 1.77 and 0.28. So that means we go back to our graph up here. Okay, we have 3 plus I. I'll choose a different color. So 3 plus I, if we take its square root, okay, we end up getting, what was it, 1.77, which would be 1.77, I don't know, a number say there, and then 0.28, which is, I don't know, point about there, which is pretty close to, so then that ends up being right there, okay, and, oh no, let's just pretend this guy's a little bit lower. 0.28 is maybe there, 1.77 is like here. That ends up giving us a number right, or a point right there. Should we draw it out? So then we see in using this part of it as our metaphor that, yeah, indeed, we cut this down, took the square root of the whole arm, which was our r, so this became only this long, and the angle theta also went down. So the square root is 1.77 and 0.28. Okay, and that's how you use Demuth's theorem to take the square root of a complex number. Do a quick recap. When you manipulate this guy, you have to manipulate the r and the angle, right? This one is to the exponent, and this one is a straight multiple. Then we use this formula that we have in red here. This is the one you have to learn. A plus or minus bi equals r plus a over 2, square root, plus or minus square root r minus a, and then that's the imaginary part. If this is plus, use plus. If this is minus, use minus. And that's basically it. Hope that's helpful. If you have any other questions, just let me know. And other than that, have a good rest of the day. See you guys.